Guys, I'm fitting up the heat pump now. The old ASZ 1424. Got it brazed in on the suction side. Fitting up the piping out here. I'm going to put some insulation on it. I was running out of insulation. I have to pick up some more. Fitting up the first one, I'm going to do the low voltages, and I'm going to go pick up the other one and we'll get the other one installed. And hopefully wrap up all our odds and ends today. Alright guys, our first Amana is in place and happy. Got to do some insulating down here on the line set. Have our second. It'll be right here. Again, here's our old unit. Not very efficient at all. Was putting out hardly any cold air, if you can believe it. Alright guys, I'm on heat pump number 2 here. Put in the outdoor thermostat. The reason why these have an outdoor thermostat is because in North Carolina you have to have a thermostat that blocks out the heat strips above 40 degrees. So we have our outdoor thermostat to do just that. Sort of a new thing. Government knows best. Y'all can agree with that, right? We have our 2 heat pumps set, the ASZ 14s, 2 tons. Ready to go, about to go into crawl space and finish the brazing at the underneath air handler and braze the 2 sections of copper together that come through the floor. And we will be just about ready to pressure check, pull a vacuum, and hopefully someone gets here to wire these things. Alright guys, I am in the crawl space where no one wants to be. I'm putting some bends on the copper and bringing it together. As you see, I bend it there, put a swage in it over here. Same thing with the 3/8 line. I'm going to braze those both up. Here's my swaging tool with some new compact swager from Hillmore. It's a hydraulic swage. It works really well. I'm really impressed with this. So this is a good product. I would definitely advise anyone who's looking for a swage to check this one out. It is not cheap, but it is definitely good. So it's worth taking a look at. And you get a lot of heads with the set. I think there's like 4 or 5 heads with the set. So it's pretty good, but I'm gonna get to brazing. I had to splice my thermostat wire here in the crawl space, so what I did was I filled each wire nut with liquid tape. Seal it up. There's a couple different connectors you can use. You can use butt connectors or something like that. It'll work too. But I use these wire nuts and I sealed them up so the moisture elements won't get to them over the years and cause them to become brittle any faster than they're going to. So I'm pretty much done over here. Finished with my brazing, got the insulation back on it. And I'm about to head over to the old air handler in the crawl space to braze it up. Well, I'm back at our crawl space air handler. As you see, I finished brazing things in, being very careful because there's some black flecks right here, and if you get that flame anywhere near the flecks, it will melt that jacket real fast. So I got my joints brazed in here. The air handlers are all finished, all the brazing is done. Just have to wire the low voltage on this air handler and finish the drain. It's heading right out that way. Let's see, there it is. And I will be done with my part. It just needs to be wired up as soon as I find the electrician. He's missing in action. I have my drain coming out of the air handler, running back over to the crawl space wall and out the wall. Have my trap in here. Have a little standing pipe as a vent. I put a little T up there just so dust doesn't settle inside the vent, but you know what? It's not a real big deal. I just leave it loose, not glued in. A float switch right here. And again, the reason I put float switches on air handlers in the crawl space, even though it's just a bunch of dirt, I just hate the idea of the drain clogging up, the air handler filling with water, and it just overflowing out of the air handler for months and months or years and years while no one knows about it because no switch is tripped. Unless you come down here, you'd never find out. It could potentially damage the ECM motor, which is, you know, sitting close to the base of the air handler cabinet. There used to be some controls right at the base. It's not too bad on this one, but there's some where the boards are right on the base, especially in a certain horizontal discharge, whether it be left or right. And when I break the signal here, I'll break it through Y, so the compressor shuts off. Now if I had a float switch, it's going to be a little bit different than a free switch. If I had a free switch, I wouldn't break it through Y unless the outer defrost board had a timer on it that would initiate a delay on break. Goodman does not have that. So if a Y signal gets cut to the condenser and then comes right back on, the condenser will come right back on. So potentially with the freestat, it could come on and off, on and off, on and off as it raises and lowers temperature over and over again. So what I do on that is either I break it through red or I break it through, like on the communicating air handlers, little CAS terminals on the board, or find a way. I break it through red to the thermostat, because if you do that, the thermostats that I put in have a 5-minute delay. So they'll go into a 5-minute lockout delay on break. So that's one way you can think of it. A lot of other systems have 5-minute delays on the condenser defrost boards, so you don't have to worry about it. But Goodman does not. So I'm going to go ahead and wire this thing up, and then I am pretty much finished. Only high voltage is left. I have my low voltage wiring run through a small grommet. What I do is I drill a hole. It's like a 3/8 hole, and put a grommet. I got a set of grommets from, it's either R.A. Michael or maybe Harbor Freight. And I just drill my holes and put the rubber grommets in there, and it protects the wires and seals up pretty nicely when you put a few wires in there. All the wires run into the interior of the cabinet. You see them right here. I'll run one thermostat wire off the terminal strip and then bring it into the other two. And then break my Y signal. Let's see. Where'd we go? It's around here somewhere. Right here. See it right there. Through our float switch. So that's pretty much it for today, and pretty much it for the job. I gotta caulk some of the holes, and that's about it. And this one is done until we start it up. We are back at our upstairs air handler. I'm gonna go ahead and wire it up. Locating an electrician to come over has been difficult, so I'm gonna go ahead and wire this one up and have them come behind and check my work. Just like I'm an electrician's helper. But you know what? It's not exactly rocket surgery. Alright guys, we're all wired up. The fan is running now. Next 13 motor. Just the fan only. And we have our thermostat here on the wall. Nice little Honeywell thermostat. Very nice. High definition. No outdoor sensor on this one, just the indoor sensor, obviously, and the humidity sensor. And the nice features that we come to know and love from the Honeywell. But I'm off to wire up the rest of the equipment, and then we'll start the testing and starting up process on all. Where we're testing our nitrogen pressure, it's been 30 minutes. We're hovering right around the mark where we started. Really hasn't budged much. It's kind of twitching back and forth, but we're happy campers on the downstairs unit. So we'll go ahead and put this into a vacuum, and then we can pressure check our upstairs unit. We are vacuuming system downstairs. About to put pressure on the upstairs system with the switch nitrogen bottles. How's that? Down here near 1,000 microns. We'll let it run for a while because it'll take a little while to get down to where it really needs to be. We'll let that run the whole time we're getting everything else ready. Then we'll probably start this one up while we're vacuuming that one. So, alright guys, let me get these tests set up and we'll keep going. Our second unit's been on pressure test for about 16 minutes and it's doing very well. Looks like it's holding pressure very nicely, even though I had a boo-boo right there. So I fixed my boo-boo. Looks like it is actually fixed. Oh, happy day. And I was just looking down here and I was thinking, man, if Goodman puts the contactor any closer to the bottom of this control panel, it'll be touching. And I see they have the Core Sense diagnostic over here. Can't really see it. There it is back there, which is a nice feature. I like that. And then I have the contactor here, so I was thinking, why don't they just put in one of the Core Sense contactors or Sure Switch or something like that. It'll take up about the same amount of room, then you'll have it all integrated into one switch. You won't have the arcing at the contactor and the pitting. Seems like that'd be a good idea. Maybe Goodman will listen if they're out there somewhere. But that would be kind of cool. I'd like to see that in the future. Maybe they'll do that. They're kind of moving that way, it looks like. So we'll see. Otherwise, units are all wired except for the crawl space air handler. I'm heading down there next, and then we can start firing these bad boys up. Well, our downstairs Amana is up and running. It just fired off. Pressures are starting to stabilize a little bit, so we're going to let it run for a little while. Looking at a day where it's going to be about 79 is the high. We're not quite there yet. Probably in the low 70s right now. We checked it on subcooling. We're going to let it run for a little while before we get to that point though. And we're still putting the vacuum on the system over here. And as soon as the first one is done, it'll be this one's turn. Alright, we're looking at unit number 1. It's pretty close to being the proper charge. We're a little bit shy on subcooling. Not too bad at all. Superheat's right about where I'd like to see it on these particular TXVs. So I'm going to add a little bit of charge to get that subcooling up a little bit, and we're going to be all set on the first one. Moving on to our second one over there. Also have a meter set up to monitor the compressor amps and volts, which we're all looking just fine. Just over 5 amps on the compressor. This is a 2-ton machine. We have added around 9 ounces of refrigerant, and they're looking pretty good. Subcooling's up near 8, bounding up near 8, going down below 8 now. So we'll monitor that, but we should be pretty close to being finished. And moving on to the next unit. The amp draw of the unit is 5.08 amps at 247 volts. I have my leads clipped to the top of the contactor to get voltage, and I have the common wire taken as it passes through the core sense diagnostic for the amperage for the compressor. I have the second floor system calling for cooling now. It's a little chilly upstairs, but the downstairs they're redoing the floor, so they had a little ventilation in there from the outside, so it warmed everything up. Upstairs is a little bit colder. But I'm not quite finished outside, so whenever I get done I can plug in the disconnect and she'll fire up. Can't see it very well back there, but there's a core sense diagnostic module. Sort of see it from the side there. It's got the common wire from the compressor in there, and it makes some troubleshooting, or it infers some things from what you have as far as low voltage signals coming in compared to what amperage you have on that line, or whether there is amperage in that line. So what there is now, if you can see it, let's see. It says lock or trip. So it's interpreting that the breaker's tripped, there's a locked rotor. And what's happened is, basically I haven't got the disconnect turned on yet. And it's calling for cooling on the low voltage side, because the low voltage is originating from the air handler. So it interprets that as a locked rotor or trip breaker. So once I turn it on, that should disappear. But whenever you're done servicing these units or starting them up, it's a good idea to make sure there's no codes on it, because you can actually cause some to happen while you're working on it. If you plug or unplug the disconnect while you're working on it, it may interpret that as a short runtime or short cycling and give you a code. So make sure to reset the codes if you cause one while you're working on it. Other than that, I think this one's ready to fire up. Alright, we've been running for a few seconds. We're starting to stabilize. 244 over 116. Subcooling of almost 5, superheat of 23, but it's going to come down as the TXV adjusts. So let's see how we do here. We'll give it a few minutes, see where everything ends up, and then start charging if necessary. We have been running system number 2, the upstairs, for about 10 or 15 minutes now. As you can see, there's only 2.5 degrees of subcooling and 18 degrees of superheat. There's not nearly as much load upstairs as there is downstairs. For example, in the windows downstairs are fans blowing hot air from outside into the structure, and that was used to speed along the floor drying. They put a coat of stain on the floor last night, which is dry now, but the load remains. But upstairs it's very low load, so the TXV is not open as far as it would be normally if it were a warmer day, skewing our pressures a little bit. So we still need to add refrigerant, but as you can see, it's a little different from the other machine. So we're going to go ahead and add refrigerant and bring the subcooling up, but it would actually be beneficial to recheck this machine on a warmer day, because the subcooling may actually drop if it were like a 95-degree day outside. So, but as you can see, the head pressure is a little bit higher here, and in fact, our amperage is a little higher as well, and that corresponds with the head pressure. So TXV does not open as much under less load upstairs. Therefore, the TXV is not open as much. You have a little bit more pressure on the high side. We get our higher pressure, higher superheat, and we're still going to charge her up. But like I said, it would be good to check this one again on a warmer day. We have added about 1 pound to the system here. We had a relatively long line set. But what I've gathered over the years is that no matter what they say as far as adding refrigerant as far as a line set, you may not get in exactly what the factory charge says it is in each unit. Therefore, it may say you have 10 pounds of refrigerant in something, and I'm pretty sure it's not always 10 pounds from what I get on the, when I tried to weigh it in on the line set side, sometimes it would not end up like it was supposed to. So, but right now we're looking pretty good, pretty close, and definitely getting a little cold upstairs. Let's see what temperature we got up there now, because we got a 98-pound suction line on the R410A here, so I think we're about done for today. We'll recheck it when it's a little bit warmer outside. It is definitely chilly upstairs. We're sitting at 63 degrees and probably a pretty low wet bulb, judging from the humidity today. 52% humidity, 63 degrees. That's pretty chilly. So that explains our 98-pound suction. We come back on a day when our set temperature is 75 and our outdoor temperature is 85 or 90, we'll get a lot better feel for the correct charge. But we are good for today. Our systems are happy, healthy, looking good, ready for inspection. We are all done. Our two 2-ton 15-seater Amanas are in place. I turned the one off downstairs because there's no point since they're blowing air through there. The one upstairs was 63 degrees, or 62, so it was plenty cold enough up there. Turned that one up to 75. We are done with this job. Turned out really good. Uh-oh. Yeah, we're downtown this time. Because I haven't shown you guys the cityscape here. And Bank of America over there. But downtown Wilmington, we're on the cusp of where it goes from good place to live to ghetto. So, see you guys on the next one. Now we're setting up our new thermostat. Inglés. Oh, never mind. And maybe the breaker's turned on. Alright guys, we're all done. The Amanas are shut down. I want to turn these... Damn it, we're running out of time. We've got to get these heat pumps in before it's too late. This house is full of the elderly. Crap. Alright guys, we're a little bit closer to where we're supposed to be. Maybe a little bit farther to go as far as charging. We're up near 8 a second ago. We're hovering in that area. I'd like to be 8 or above here, because I'd like to recheck it. But if it becomes 95 degrees outside, I don't want to be... Damn it, we're running out of time. We've got to get these heat pumps in before this house gets too cold for the elderly and orphan babies that it's filled with. We must do it. We must do it today. We haven't got any time left.